What's going on? This is SDG Labs. My name is Anastasio Dalde. Let's do some math! So, here's what I'm going to do. I've got a graph, and this graph is f of x equals 2x minus 1. Now, what's the slope? 2 over 1. It's the number in front of the x, right? This right here, does our graph start at 0, 0? Because all of our other graphs started at 0, 0. If I plug in x equals 0, what does that y value give me?
That means somewhere they get to 0, right?
If I plug in x equals 0, x equals what? Y equals what? Negative 1. That's telling me that my graph doesn't start off at this 0, 0 point, which is nice and convenient, which is what I've always liked. It starts off at x equals 0, y equals negative 1. That's the point where it starts off. Cool? What's the next point? How do I get to the next point?
2.
1, 2.
Oh no. Yeah.
Yeah?
And then over 1.
Yeah, perfect. So it'd be 1, comma 1. That's your next point. Does that make sense? All right, let's try another point. Or here's another thing that they do, is they're saying verify that negative 1 comma negative 3 is on that graph. Well, there's two ways to do that. We can do it mathematically without looking at the graph at all. Plug in negative 1 into here. You have 2 times negative 1, which is starts negative 2. There we go. Minus 1. What's negative 2 minus 1? Rhymes with the word tree.
3.
3. 3, not positive 3, but
Negative 3.
negative 3. Exactly. See? You plug a negative 1 into here, you get negative 3 out.
Negative 3.
So we verified that that is on the graph. Or on that this thing solves that equation. We can also verify it that it's on the graph if you look at over here. You're starting over here. If I go 2, 1, if I have positive 2, I go up 2 and across 1. That's the slope, right? I would argue with you that that's the same thing as going negative 2 over negative 1. Because what is negative 2 divided by negative 1?
Negative P.
What?
It looks like a P. I see. One.
What is negative 2 divided by negative 1? What's a negative divided by negative? What? A positive. Are you sure? Say yes, I'm positive.
I'm positive. Positive.
So negative 2 divided by negative 1 is positive what? 2. So let's say the same thing. So if my slope is positive 2, I can actually go backwards 1 and down 2. Backwards 1, down 2. Or actually maybe we'll do the rise first is down 2, backwards 1. What is the coordinates of this point right here? What is the coordinates? So come on, say it. Negative 1 comma negative 3, absolutely. Look, it's right there. We've verified it mathematically. We've also seen on the graph that it is on this line. Does that make sense to you? Now here's the tricky part. Oh, and this point right here is 1 comma 1. All right. This is negative 1 comma negative 3. Here's the tricky part, and here's the important part that I want to show you, is you'll often be given 2 points, and a lot of times you'll be asked to calculate the slope that is in between them. What's the slope? So let's choose 2 points. This is 0 comma negative 1. All right, let's choose 2 points. Let's choose this point over here and this point over here. What's the slope in between them? Do you understand what I mean by slope? What is the m between 1 comma 1 and negative 1 comma negative 3? I think the easiest thing to do would be would be graphically. Take a look at this. If I start here and I want to get here, what is my rise and what is my run? If I start here and I want to get here, how much do I have to rise by? Look at it. 4. Good. How much do I have to run by?
2.
2. 4 over 2 is also known as 2. My slope is 2. Does that make sense? Mathematically, if I didn't have the graph, what I would do is I would do this. What is the slope between points 1, comma 1 and -1, comma -3? Now this is important. This is probably the more important, is because it's easy to do it graphically. And often what I do is I graph them and I count it out. That's what I do. But if you're asked to do it just mathematically, what I would do is this. This y value right here, if I want to figure out the rise, that's the change vertically, right? I usually write that as delta y. The delta just means the change in. How much does this change by? You get it? The delta x is my run. How much does the x change by? This is the y values. Here's my x values. So what I mean by delta is I mean the final value minus the initial value. Right? That's how you would figure out the change in something. Does that make sense? Mm-hmm. So the final value is 1, right? You can kind of think of these deltas as y final minus y initial, x final minus x initial. What is the y final? What is the number? 1. Minus, what is the y initial? -3. Notice how I put the parentheses around there. That's important. What is the x final?
1.
1. What is the x initial? All right, so what is 1 minus -3? You're raising your hand.
-4.
You have 5 fingers up, so you, no, the answer's not 5.
It's 4.
It is 4, yeah. Because this minus -3 is actually, you know, cancels itself out, and then you get 1 plus 3 is 4. Does that make sense? What is 1 minus -1? 2. Positive 2. That's equal to 2. The slope is 2. So I did it graphically, which was very easy. I did it mathematically, which wasn't as easy, but I got all the same answer. Here's another one. I'm going to switch it up on you. For this problem, I call this the final point. I call this the initial point. Right? What would happen? I'm going to ask you to predict real quick, and then I'm done. And then I'll just be done. All right? I'll back off, I'm done. What would happen if I switched that? What would happen if I made this the initial and this the final?
You get an upside down.
What would you get? Would I still get positive 2? Yes or no?
Yeah.
Yes, yes, yes. I'm using different points. I'm going from here to here. Instead of going from here to here, I'm starting here and ending here. Initial, final, right? Will I
Isn't
still
that
get
just like
positive
the-
2?
Isn't that just like
Yes.
backwards what you were talking about, the run over rise instead of rise over run?
No, it's not the run over rise. We're still doing rise and run.
No,
let's try.
I mean-
Let's just try.
I meant-
Y final is what? What is Y final? What is it? -3. Because there's the final. That's the Y coordinates. What's the Y initial? 1. There we go. Over X final. What is the X final? There we go. What is minus X initial? 1. -3 minus 1 is -4. -1 minus 1 is -2. That's also known as positive 2. Are you comfortable with that, or does that kind of freak you out a little bit? Be honest.
I like the graph version.
I think that makes sense because you're still graphing the same points on the same line, but they're just in a different order.
Yeah.
Again, they're still the same line, so it doesn't matter.
I think what this is saying is if you go from here to here, your slope is going to be up 4 across 2, or it's going to be 2. You're going to go up 2 across 1, up 2 across 1. Does that make sense? Versus if you go from here to here, you're going to go down 4, backwards 2. Well, down 4 and backwards 2 is the same as going up 4 across 2. Right?
Yeah, just back.
So that's what it's saying. So you can choose any of these points, any 2 of these, in any order you want. As long as you are careful with plugging it into this equation correctly, you will get the same answer. Is that all right with you? All right. I have a problem with memorizing equations. I hate it. I think that biologists are crazy. They memorize like everything. I think the chemistry people, crazy. As a physics guy, I memorized like a page of equations at most in the 20 years that I've been doing physics, and then I basically say, I don't memorize anything. I'm going to derive everything. What I want you to know is that slope is equal to rise over run. I kind of don't want you to memorize that equation, but I kind of do. I think that you should know what this equation is, but really understand that all this is, you're going to see this as m equals y2 minus y1 over x2 minus x1. All that is saying is it's equal to the change vertically divided by the change horizontally. And when we measure change, we take the final thing minus the initial thing, right? If I have, like for example, if I have 10, or if I am standing 10 miles away from my house, how far did I run?
10 miles.
What do you guys say? 10 miles, 10 miles, 10 miles, 10 miles?
Whoa.
No, it depends. Depends on where you started, right? It depends on if you started 7 miles already away from your house.
Oh.
The change is only going to be 3 in that case.
All he told you was that you.
So all I said is I'm standing 10 miles away from my house. I didn't tell you where I started. So the next question is, if I ask you, I'm standing 10 miles away from my house, how far did I run? Well,
Where did you run
where did you
from?
start? Right? Like I'm standing technically about like 20 miles away from my actual house. How far did I run? I didn't run 20 miles. I ran a couple blocks. I didn't even run a couple blocks. I walked a couple blocks because the bus took me from here to there, and then I started, 98% of the way there, and then I just walked the rest of the way.
You live 20 miles away.
Yeah, I don't know how far Whiteview is from here, but
Like Peel?
yeah.
It's not 20 miles.
All right. Anyway, yeah.
Jeez, that's far.
You know what? As a physicist, I just say, oh, it's a distance d, whatever it is. Just let it equal the variable d. All right. Anyway, does that make sense to you? Whenever you find the change in something, if they tell you the final, well, then what is the natural question you should ask? Well, where did you start? What's your initial? I can't tell you what your change in y is until if you tell me just the y final, you need to tell me the y initial as well. That's why the delta y isn't just the number -3 or the number 1. It's -3 minus 1. Does that make sense?
Mm-hmm.
Also, you can even do it in different orders, which is very important for you to understand. Cool? Shoots, bro. Up out.